Hello everyone, and welcome to the third video of the Python Fundamental series. Let's get started. Possibly the most used data types in Python and programming in general are the numerical data types. If you remember from the first lesson of this chapter, we talked about how in Python there are the ints and floats. Today, we're going to be talking about some of the more advanced features that deals with numbers, as well as introducing the complex number data type. The first things that we'll be looking at is the int and float functions. If you remember from our last video on strings, we talked about how we can use the str function to convert non-strings into strings. The int as well as the float functions, they do the same thing, just with int and float instead of strings. Unlike the str function, only certain values can be passed into these functions. If we pass in a string like Python into an int or float function, a value error will be generated because there is no number within the string. We can also pass in booleans into the int and float function because Python recognizes true to be 1 and false to be 0. Taking a look at the code cell below, we would see that 2 and 5 are both assigned string values holding a number. So, in order to perform an arithmetic operation on those two strings, we would first have to convert them into a numerical data type. We can do that by passing those strings into an int function, which would return to us an integer 2 and an integer 5. And then we can multiply them together, giving us the integer 10. And to concatenate it together with this string, we'll first have to pass it into the str function, which allows us to combine those two strings together. And if I run this cell, you will see that 2 times 5 equals to 10 is indeed printed out. Looking at the second half of this cell, we will see that true holds the value of true and false holds the value of false. If we convert true into an integer, we will print out 1. And if we convert false into a float, that would give us the number 0.0. The next two parts of this video is going to require some kind of understanding of scientific numbers and complex numbers. But don't worry if you don't quite understand them yet, because neither of these concepts are particularly important in a programming context. Firstly, scientific numbers. Scientific numbers is a way how we can express extremely large or extremely small numbers, showing numbers in the format of a coefficient a times 10 raised to the bth power. And in Python, we can replace the times 10 to the power part with the uppercase or lowercase letter e. Looking at this example, we can see that a number is assigned the value of 9.218 E3. What that means is 9.218 is multiplied by 10 raised to the third power. Printing it out, we can see that it is of type float and holds a value of 9218.0. We can also modify this so that it is a negative exponent, and if I run this, you'll see that it's 0.009218 instead. Other than int and float, Python also supports the complex number data type, which is made up of a real part and an imaginary part, the latter of which being a multiple of the imaginary unit I. Python denotes a complex number's imaginary part with the suffix j and not I. For example, if we have the complex number 1 plus 2i, it would be 1 plus 2j in Python. And as you can see here, if I have this complex number, it will be of complex data type and hold a value like this. Complex numbers also can be used with mathematical operations that can be done to ints and floats. For example, we are adding a complex number defined here to another complex number defined here, and if I print out the sum, you'll see that they're added up together. And just like int and float, it also has the complex function, which takes two parameters, the first of which being the real part, and the second of which being the imaginary part of the complex number. However, we don't have to give it an imaginary part, and if we just give it one part, then it will just assume that the imaginary part is 0. And in this case, you can see that these are printed out nicely. The last section of this video is going to be on incrementing and decrementing variables, something that you will do over and over again in programming. Right now, we have the payment variable assigned the value of 10, and the text variable assigned the value of 2.5. If we want to increment payment by tax, then the simplest way to do it will be payment is equal to payment plus tax, noting that the equal sign is actually not the equal sign, but instead the assigning operator. If we print out the payment value before and after incrementing it by tax, then we will see 10 and 12.5 printed out. The better and more popular way to do the same thing would be using the plus equal sign. Payment plus equals tax is the same thing as payment equals to payment plus tax, and if we print it out, we'll see 10 and 12.5 printed out again. A plus equals to B is a shorter version of A equals to A plus B, and the same rule also applies to the other arithmetic operators like these. To summarize, let's talk about what we learned today. In this lesson, we talked about the int and float functions, which we can use to convert data into ints and floats. And then we went over scientific notation in Python, as well as how we can use the complex data type. Lastly, we talked about how we can increment and decrement variables in Python, but really, it can be any other arithmetic operator as well. And that's it for this video. If you have any questions or concerns, please leave them down below in the comments. With that said, thank you for watching, and I'll see you in my next video.